Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi and we continue with our chemistry topic of discussion, and we are discussing reaction rates and reversible reactions. So the next factor that we shall discuss is light. So light is a factor that affects the rate of reaction, but as mentioned earlier, not all reactions are affected by light. We have particular reactions, and we refer to these reactions as photochemical reactions. So photochemical reactions are those reactions whose progress is affected by the presence or the absence of light. So we can say that light affects the rate of photochemical reactions, such as A, in photography. You'll find that during the development of photographic films, that development is usually done in a dark room. And it's done in a dark room because those photographic films have a layer of silver bromide. And that silver bromide, on exposure to light, it tends to decompose. On exposure to light, it tends to decompose. And that's why that development of photographic films is done in a dark room. So you can say that photographic films contain a layer of silver bromide, which is yellow in color. However, when exposed to light, the layer decomposes into silver and bromine. Hence, the color changes to gray. So you're saying that silver bromide found in photographic films is yellow, but when it is exposed to light, it decomposes into silver and bromine, and it forms a color that is gray. So in such a reaction, we find that that explains why development of photographic films is done in the dark room. So you're saying that this explains why photographic films is done in the dark room. Another example of a photochemical reaction is the reaction of hydrogen and chlorine to form hydrogen chloride. So also that reaction requires the UV light. So hydrogen plus chlorine. So that reaction does not occur at room temperature. So it requires the UV light to form hydrogen chloride gas. So you're saying that this reaction does not take place at room temperature. But when exposed to ultraviolet light, the reaction is explosive. So the reaction does not take place at room temperature, but in the presence of UV light, ultraviolet light, it's explosive. Another example is the reaction of methane with chlorine, which also occurs in the presence of UV light. It does not occur in the dark. So we have and we form chloromethane. So we form chloromethane. So we are saying that that reaction occurs only in the light. We have the common reaction, we know, photosynthesis. And this is where carbon 4 oxide and water combine in the presence of light to form glucose and oxygen. So that's a reaction that again is a photochemical reaction. So we have seen examples of those reactions that are affected by light, what we are referring to as photochemical reactions, such as in photography, such as in the reaction of hydrogen and chlorine. We have the reaction of methane with chlorine, and we have photosynthesis, whereby CO2 plus water combine in the presence of light to form glucose and oxygen. So we are saying that carbon 4 oxide plus water, we form glucose plus oxygen. And then we can balance the equation. So basically we are saying that these are examples of reactions that require light for them to take place. And therefore we can say that light is one of the factors that affect the reaction rate. So the assignment, and the first question, name 4 photochemical reactions. B, write chemical equations for the photochemical reactions above, each of the reactions mentioned above, or you can say in A, above. Explain why photographic films are developed in the dark room. So we'll stop there. Until the next time, goodbye.